What are we doing today? Well, I've got some of these Appley Mac top toshing batteries. I don't own a laptop Mac myself, but well, how did he want to be referred to? A handsome young gentleman by the name of Byron, that's how he'd like to be known, has given these to me. He's bought a Mac and had some trouble with batteries. It came with one of them, I believe. Probably, I don't know which one it came with. One of them's meant to be new, but they're both a bit scratched. But one of those was new as a replacement. The other one came with the Mac functioning. Then experienced some problems with it not charging up, and then the battery ran out, and of course it wouldn't work, it wouldn't charge. Bought a replacement. That didn't do anything at all, just didn't work, didn't charge at any point. And then went ahead, found someone else who tested it with an authentic battery. It worked fine and charged. So he's now gone ahead and bought a new battery altogether, an authentic one, and that does seem to be functioning fine. So I was going to have a quick look inside these, have a look at the quality and see what might have gone wrong with one of them. I did notice, I don't think it's that one of them smelt. Yeah, it's this one here. Smells bad inside, okay? So it's kind of got that telltale smell of burnt electronics in there, so smells. Let's get in there and have a look. Yeah, that's a problem, isn't it? So the screws in this unit are not a posi, they're not a flat blade. They are one of these little tri-star type. Would you believe it? I've got a whole set of various security bits here, but there is no sign of a tri or a three-bladed screwdriver, so I can't actually get in there. Let me see if I can get a very, very small flat blade in. What's this, a 1mm flat blade? Will that jab in there and do anything at all? Ah, perfect, it does. The end has broken off this one. One of the things I was a bit concerned about when I had a look in here is these screws on the back here, they actually come through the metal case. This one does have a metal case, and they go through a little black bracket and into a hole there, and they actually poke into the top of the circuit board. Let's have a close-up of that. You may or may not be able to see that where the screw came through into there, it didn't actually kind of fix into the circuit board, it just kind of jabbed into the surface of the circuit board. That one, and that one. So hopefully where they jab, it doesn't kind of break into the copper of the circuit board. Otherwise this whole case could become a short itself. That would be very bad. So I have taken all these screws out now. Do you think that end needs to come out? Do I just pull? I'm going to give it... No, there's a bit of movement there, so I'm going to keep pulling. Don't want to break these wires and short them. Oh, look at that. They're just these kind of like pouch type batteries with a bit of foam around it. So there are 1, 2, 3, 4, 5, 6. They almost feel a bit warm, which is a bit worrying. These, of course, if I punctured these or tore them, would go off into fire if they're fully charged. That would be very, very bad. I would literally have to turn around at high speed and throw them out into the garden, into the gravel, and then go put them in a bucket of sand and hope for the best. Don't really know what to do with them once they go volatile like that. None of these are swollen though. They look in reasonable condition. They're nicely sellotaped together with what feels like standard sellotape. Then there's a bit of kind of masking tape in there to cover up the electrodes, and that's scary as well. So this electrode here, there's actually a piece of metal poking out through there. That's actually a metal spike off the end of one of these batteries, and inside here is an aluminium case, and inside that case is no form of insulation in there. And there we have it. Oh look, there is actually a piece of tape exactly where that metal spike was sticking. So it's almost like when they've assembled this thing, they're like, oh, there's a piece of metal poking out there. We better put some tape just there where it might actually short. And they're like, well, what about all the rest of them? And like, oh, well, hopefully they won't break through their insulation tape and short out. And yeah, I can feel that there's no sharpness there, so it's almost like they won't. But there's a sharp bit poking out. Okay, I'm glad I'm not running this. I'm glad Byron isn't running it anymore either, and that he's got an official Mac one now. So what's happened in here? We could smell some burning, so I'm going to have a little investigation in here, see whether we can find out what has burnt. Right. Okie dokie. These wires are tiny. We've got 1, 2, 3, 4 wires. So it's configured as an S3 or a 3S, 3 cells, 2 cells per gang, as you might call it. Power density wise, they're saying this is about 45 watt hours. Can I find any burnt parts? I'm going to bring it up here and have a sniff. Hopefully we've got enough focal depth here to actually see the problem. Well, first of all, this wire here, there's loads of little strands of it just kind of poking up. So I guess when it was pushed in or given a squeeze, it looks like there's some sort of insulated glue being put on there, but they missed that wire altogether. The actual damage is in this location right here. There is these are all a bit cooked, and then this little resistor, I'm presuming, maybe a current sensing resistor, or is it a fuse? No, it's listed as an R020, which might be, I might be mistaken, but like a 0.2 of an ohm resistor. If we look under here, let me refocus, a bit too close, that it's actually completely and utterly cooked. See it on the end there? It's this resistor here is completely gone. It's foobar. There she is. So that's what that cooked smell was inside this battery, is this little power resistor that has not done too well with whatever condition has caused that to explode. So I'll bring the meter of the multi into the equation. We'll have a little test of these battery packs and just see what's happening. I'm going to trim these off the board. Little tip is, when you trim these, is try and not trim them the same length. So if for any reason they come together, they're less likely to short. If they're all the same length, it's quite possible you could accidentally touch them. And also notice the longest wire, which is the black, I'm happy to cut as the shortest because I've got the most of it to go with. So all those wires are lined up in a way that they won't short out. Because of course, now we've got no protection circuit, these are, well, susceptible to being shorted out and catching on fire, especially if they're fully charged. Let's have a little look at what these are. Very, very careful not to damage the... Well, that is a short situation there. Need to be very, very careful that these don't touch each other at any point. I'm doing this so you don't have to, and if you do it and you have a fire, that's your own fault. Just to prove that I'm taking things quite seriously, I have this right here, and as I said, a bucket of sand outside. First alert. So let's have a quick probe using my pointy probe sticks. I have got, let's assume that ground is down there, and the next one along is there. I'm reading 3.7 volts, which is kind of a flat state. Reading what looks like the next cell along, which is going to be yellow to blue. About 3.8 volts, so that one's got a slightly bit more charge in it. And then finally this one here is 3.8 volts. So again, pretty much flat. I think they're about 3.7 volts or 3.6 volts completely flat, and about 4.2 volts full. So they all seem like they're alive. They've got charge in, they're not completely dead. They're not swollen. So the fault itself, definitely that little resistor on the board. Here are some other lithium polymer battery management boards I've got. So these are some little 1-cell boards. I use these with the 16 or the 18650s. Solder or connect up one end of the cell to one pole, the other pole to the other end. Then you take your power and your charging off two of the other contacts. This thing has a short circuit protect, overcharge, over discharge and over current protect. So very useful, need those to keep things safe. Then that's for 1 cell. I've got some others down here which are 4 cells. So these are slightly bigger. These ones manage 4 cells. That's also a 4-cell one. This is one that's come out of a mobile phone battery for a single cell. These are ones that have come out of a drill battery, a lithium ion drill. This one's actually got some thermometers on board as well. It's going to actually monitor the temperature of the batteries. I guess it charges the batteries as fast as it can until they start getting hot and then reduces the current. You'll find similar circuits in these power banks. So this is a little dual cell power bank charge circuit with a built-in torch as well. This is a slightly bigger one, I believe with a solar charger. And there's some 2 cells, and I've got a whole load of 3-cell ones here. What I'm probably going to do here is use one of these new 3-cell ones, solder it up onto this battery pack, put some charge in there, see how it behaves. Before I do that, I'm going to strip down the other battery pack. And for safe measure, I will definitely cover these wires. Safety first. We will save that one. Oh. At no point do I want these wires coming into contact with themselves or anything conductive that may cause a short circuit, because that is a surefire way to fire all the way. I don't know. And of course, for extra safekeeping, I will try and stick it in this lipo-safe bag, which is supposed to be able to withstand fire and flame inside it. Whether it does or not, I haven't got around to testing it. So this battery here, let's have a look at this one. There doesn't seem to be any screw fixings on this. There are no screw holes. How do you get in there then? Do you think they've ultrasonic welded that together? Or is it just popped together? Problem with it being ultrasonic welded is if I'm getting a screwdriver in there to pry it open, I don't want to short anything. I don't want to puncture the battery. Go on. No, it's not having it. What about if I get the colours in the end and peel this back? Friday afternoon, I don't want to have to get too involved. Flimsy that it's just pulling apart. Oh, so what's happened there? There was double-sided tape in there. Now the double-sided tape has pulled on these bags, but they don't seem to, well, these are pretty shoddy cells, to be honest. The plastic encapsulation, or the little sacks they're putting, are quite baggy. There's a lot of play in it. I'm kind of rubbing this down, but I don't want to pinch or trap anything. The wires are better. They're a thicker gauge wire. They are, compared to the other pack, the little PCB is much smaller and the batteries are further up this way, and that's resulted in quite a gap down here. So there's a smaller protection circuit in there. I want to be careful peeling this back. It's just double-sided sticky tape in here. People say, oh, yeah, surely you can't just tape stuff together. Well, tape in the right place, no one will ever know. Loads more sticky tape. The cells have got some stickers on them, so I wonder who made them. The difference being here is that these cells are singular cells. There's 1 cell, 2 cell, 3 cell, whereas the other one had 6 cells in total. I'm a bit curious as to this charger board up this end. Yes, much smaller affair. It's a similar type of affair though. It's got 2 chips there, that chip there. So it looks like it's actually does the basic same job. It's just they've managed to fit it on a much smaller board. I bet if I counted the little resistors and capacitors, they're the same. It's a little transistor, yeah. What are we missing? It looks like, I'm going to get in a bit closer here. Oh no, there's our little resistor. This one is an R010. So this one was before I destroyed it, a 0.2 of an ohm. I think this one is a 0.1 of an ohm, which is much lower resistance in comparison, and therefore this one doesn't seem to have died. I wonder what's happened to this one. I can't find... I can see that the numbers are being rubbed off these chips. They might just be legible, but I'm not going to go too hard on them. It's just a charge controller. And we have got the wires much again glued in, but these are a much stronger type of wire here. The other ones felt very flimsy. This one seems to have more copper in it. And again, I can't see a failure on this board as such. So I don't know why this one's stopped going. There's nothing blown to bits. Be interesting to get some cell readings off this one. 3.6, 7.2, and 10, which is, yeah, 6. So again, these cells are all dead, they're all flat, but they're not actually unhealthy, they're just sat there flat, and the charge controller is not passing the current to them for whatever reason. Am I getting any voltage up here? Well, we've got one of them is T, which I believe would be temperature. So there does seem to be some voltage on that one, but it would seem like whatever this does to communicate to the Mac to allow it to charge is not happening, and it's sat there in a flat state. These cells are bigger, thicker cells. They're quite nice cells. They're rated at 4,200 milliamp hour each. They could be possibly useful. I don't know about the current loading on them. The insulation is definitely better. So although that one was in a plastic case, it seems to have been a slightly better quality battery inside that plastic case. The other one, which was inside the metal or the aluminium case, which it is aluminium, seems to have been a slightly maybe older design. The cells seem to be almost like repurposed mobile phone cells, or maybe the kind of cells you'd find in a tablet. I don't think you'd be finding these cells in a tablet because they are quite thick. They're nearly, what, 8 or 9 mil thick. So, there we have it. That's goodbye from the multimeter and goodbye from me.